Ladies and gentlemen, please welcome Tom Korn.
Thank you, everybody. Thank you, everyone. Welcome. Welcome to our security keynote. We're very excited about this keynote this year. It's obviously a very big year for security for VMware. A lot of big news in the security area. And for those of you who've been following us carefully over the last few years, we laid out a strategy and a vision a number of years ago. And what you see this year is really the logical next step, the next chess move in what we've laid out several years ago. So what I'd like to do today is I'll try to provide a lot of that news in context, sort of frame it so it's clear about our strategy and our vision and where some of these things fit in. And then we'll dive deeper into a bunch of different areas. And as has become tradition in our security keynotes, we started this a few years ago. We want to make it real. And a number of years ago, we started this tradition of doing live attacks on stage. So we actually set up a data center in Palo Alto. We have a series of applications. We're going to bring on a red team and a blue team, and we're going to execute these attacks and defense live. Now, anyone will tell you it is insane to do a live demo on a main stage. So many things can go wrong. And just for the record, it is in fact true that yesterday when we ran through this, the power grid for the 3-block radius around here did indeed go out. But I can assure you that officially, we had nothing to do with it. Let me begin with the following phrase. An ounce of prevention is worth a pound of cure. Now, we've all seen and used this phrase many times before, and it's conventionally used to mean that the effort we expend in trying to solve something before it erupts into a huge problem is so much more effective than all the effort we expend afterwards trying to deal with the problem. But few of us actually know really where this originates. And it actually comes from an article in 1735 in the Pennsylvania Gazette. And that article was actually about firefighting. See, it turned out that fires had become an enormous problem in colonial America. Cities like Pennsylvania and New York and London had a massive problem, hugely expensive fires that would take out large portions of the city. Now, firefighting had been something that had been increasingly invested in and increasingly had lots of innovation over centuries. You know, if you went back to the early Roman period where you had bucket brigades trying to carry water over long distances to where there were fires, or if you went to the medieval period where they introduced the earliest form of a pump, an injection device that would make water flow over a large distance into flames, or in the early modern period where we introduced sort of the earliest version of a fire truck where we could transport equipment and people and water to wherever we had fires. And over this period of time, we saw a steadily increasing investment in firefighting, and also an escalating cost of the fires themselves. It seemed like the only thing growing faster than our investment in firefighting were the costs of the fires. So what this was no more apparent than in colonial America. Now, to understand why, you have to picture these cities where different buildings were packed together, people were packed together. There was a lot of fuel sources like coal and chemicals for tanneries. There were open flames everywhere in the city, and something would ignite somewhere, and it would spread rapidly through the city, moving from house to house, building to building. It was becoming a devastating problem. And what the fellow who wrote this article was basically saying is, we have to stop starting this from a reactive way of just looking at the end and saying, how do we deal with a city that's on fire? And we have to start more in the beginning and thinking about prevention. And he started to introduce this idea that let's start looking with predictive measures. Where do we have fuel sources in our city? Those are the places that fires are more likely to start. How do we think about prevention in a different way? He started to introduce regular chimney sweeps. He suggested we use warming pans where possible instead of open flames. How do we have much earlier detection of fires? So we installed town watchmen at various locations in the city to watch over the rooftops. And response. He actually introduced the first professional firefighting force in America. And this started a trend and a way of thinking that has continued to this day. So we have today advanced analytics to predict, for example, forest fires. We have building codes to essentially create buildings that don't burn. The advent of smoke detectors to have much earlier detection of fires before they become a huge problem. And then ultimately things like sprinkler systems in buildings so that we have rapid, targeted, granular response in an automated way. These things have made an enormous difference on how we protect people and property. An ounce of prevention is worth a pound of cure, and it struck me as we were preparing for this keynote how close this analogy is to the cyber issue today. In fact, we often talk about it as firefighting. Now, in colonial America, we were protecting people and property. In the modern world, we're trying to protect applications and data. But this notion of how do we have a framework for how we predict where we have our critical assets or where we have our major risk, how we start focusing more on prevention, things like hardening systems, creating least privilege, zero trust environments, right? How do we have much earlier detection and much more targeted detection? So the advent of endpoint detection and response is becoming far more significant today. And how we have much more automated remediation. Traditionally, these have been silos. These can't be considered silos. Traditionally, we thought about incident response. Today, we have to be thinking about continuous response. Today, we live in a state of compromise, and we have to be treating our environments this way. I like this particular framework. It was developed by Neil McDonald and Peter Firstbrook at Gartner, and it's called the Adaptive Attack Protection Architecture. It's part of their sort of CARTA framework, or precursor to CARTA. And I think it really starts to shape how we need to be thinking, and it's very much in line with what the writer of that article was starting to suggest, about starting to think differently about this problem. Now, applications and data sit and are running on and are accessed by a handful of things. They run on workloads. They communicate across networks. They are accessed, they are run on public clouds, not just private clouds. They run on user endpoints or accessed by user endpoints and by users. Now, the way we are protecting these things today is this. The average organization owns between 60 and 100 of these. And I've actually been in several meetings where someone's looked at the chart and said, I think I own all of these, right? This is as much the problem as it is part of the solution. We have all of these products, different products at the endpoint, different products on workloads and servers, different products on user machines or for identity or in the public cloud. This is very bolted on with a whole litany of agents and appliances, each with their own consoles, each with their own policy sets. Misconfiguration and misalignment of these controls is leveraged in 90% of breaches today. It is also very reactive. An emergency room is not the right place to be focusing healthcare. At that point, right, that should be the last resort. We need to be thinking about how do we harden our environment better, and we need to be thinking about how we have much earlier detection of issues. It is too much of security is about reverse engineering or rethinking the attacks of yesterday, as opposed to how are we proactively thinking about the attacks of tomorrow. And it is very siloed. Network teams focusing on firewalls, endpoint teams focusing on endpoint security, the public cloud security teams, the InfoSec and the SOC. Security is a team sport. This can't exist in silos. And by the way, the attackers don't think in silos. The attacker starts compromising an identity or getting on a user device to compromise a workload to move laterally across the network. Security has to be transformed. It has to move from a bolt-on model to much more of a built-in model, where security is a distributed service. It's part of the fabric of the infrastructure. It has to move from this reactive model that's about reverse engineering the attacks of yesterday to a much more proactive model that's focused on understanding the behavior of the thing you're protecting. And it has to move from this siloed model to a much more aligned model. We have airports in cities all over the world. We speak many languages across that, but we have a common language for the air traffic controller so that everyone can communicate across a single thing. Security needs something like that. Now, Pat laid out VMware's overall strategy and vision, which is about becoming the digital foundation for any application running on any cloud, on any device. The security strategy is about leveraging VMware's position across this picture, because we have a very unique position on those workloads. We have 60 million workloads running on vSphere and ESX. Think of all the NSX and all the virtual switches that are out there. We have over 10 million workloads on public cloud. With Workspace ONE, we have this incredibly large universe of population using this for managing the posture of the devices and access. And our security strategy is about leveraging what you already have, leveraging that position, because these things have unique visibility and unique context about the applications and data that we're trying to protect. It's about leveraging that along with analytics to make sense of that, to be able to apply back to those control points where we now have this flexible enforcement point to enforce policy or enforce security decisions. This is what we're referring to as an intrinsic security layer. And to be sure, it doesn't exist in a vacuum. It needs to work alongside whatever products that you have. And we have taken it upon ourselves to go deeper with a certain population of very strategic partners to do deeper integrations, deeper alignment, workflow design. Now, a good example of that is Carbon Black. And about 2.5 years ago, we started to do a very deep relationship with Carbon Black. We loved their vision for what they were redoing and rethinking on endpoint security, which is candidly going through a transformation, the likes that we only saw in network security with the advent of the next-gen firewall, and now is starting to occur on the endpoint. We had a very similar vision, and we started to work closely in deep integrations with AppDefense and Carbon Black, and then later with Workspace ONE. And of course, as you heard the news late last week and in Pat's keynote on Monday, we've announced our intent to acquire Carbon Black. This is a huge move for us and for the industry. Carbon Black is a leader in the endpoint detection and response market. They practically invented this modern EDR. Their security cloud and their EDR solutions are leveraged by over 5,600 customers and used by over 500 partners. And what Carbon Black brings to the table that is so powerful is this cloud-based analytics, the security cloud that leverages big data analytics and AI machine learning techniques to be able to take the same kind of data that we have access to, understanding and the details of the application and how the application is running and how the application is interacting, and take the data once, and then to be able to use analytics to start rethinking how next-gen AV works, or EDR, or rogue system detection, device control. And we will be taking AppDefense, which we have been working very closely with them, and operates on almost the same data. And now AppDefense inside can provide application control to the security cloud, and will provide vulnerability management. Earlier this week, we announced that we've built vulnerability management right into AppDefense. There's no more scanning. The hypervisor is going to be in real time monitoring what's running on top of it. In real time, you'll see vulnerabilities. In real time, you'll prioritize those vulnerabilities. And that all becomes part of this security cloud. But even more than just adding functionality, what we can add to Carbon Black is the context of the applications and the topology. That's the common language that starts to align security at the network and at the user endpoint and at the workload and with identity. That is the air traffic control language that all pilots from all over the world, even though we all speak different languages, now speak a single language. And we can start aligning around what we're trying to protect. It's going to give us an opportunity to make this agentless on vSphere, unified on Workspace ONE, embedded in NSX to do threat analytics across the network, and integrated with our secure state technology for what we're doing with the public cloud. And I'll show you pieces of what we're doing on each of these fronts shortly. And of course, work with an ecosystem of partners, obviously with Dell and with SecureWorks, but with Dimension Data and IBM and Optiv and others. So, intrinsic security, the intrinsic security layer. What I'd like to do first is dive into workload, and then I'll sort of walk around each of these areas. And I'll start with workload. Now, workloads and endpoints, they're both endpoints. But there are some different characteristics. Whereas a user endpoint has many pieces of software, is controlled by a user, is a multi-purpose device. A workload is kind of unique in that it is part of a larger application. It is single purpose. The app server, it's part of a patient care system, does one thing. And it is administrator controlled. Now, one of the frameworks I like here is actually Neil McDonald's framework on cloud workload protection, which is basically he stack ranked all the things that you could do to protect a workload in order of the amount of risk that it addresses. The idea is that, what's the thing you can do that can address the most risk? Patch, harden. I know we talk about 0 days a lot, but 0 days are actually expensive to develop, and I'm only going to use them as an attacker when I need to, and candidly, I rarely have to. Right? Harden, patching, segmentation, system integrity, OS integrity, app control, encryption. There's a whole bunch of things that we can do to get huge amounts of risk off the table. And then it's critical to do things like endpoint detection and response, et cetera. But there is a huge opportunity to rethink on the workload, the huge amount of risk about hardening it. And it is this piece that we have an opportunity to really make a big difference that we have not seen in decades. And I think it goes back, honestly, to the earliest principle of computer security, the principle of least privilege that was developed in the early 70s by Salter at MIT. A system should be able to do the things it needs to do to get its job done, and nothing more. It's very simple. It's the military equivalent of need to know. But it's actually hard to do. And it's hard to do because few of us understand our applications and how our applications interact with our infrastructure. But it just so happens that we sit right in between these two layers. And you have it everywhere. And that gives us a unique understanding about what's running and what was provisioned in the first place. We get to do it without agents. And more importantly, we get to do it from a separate trust domain, so that if an attacker has root on the machine, they can't just turn us off. And we have this flexible enforcement point that if we want to snapshot the machine or kill a process or quarantine it, all of that is something we can run anywhere. The fabric itself is software. So think of an app as a series of workloads and services. What AppDefense is doing is using analytics to help instrument your workloads. So now it's not just baselining. It's classifying and validating and saying each workload, this is its purpose, this is its role, this is its composition, this is its intended behaviors, this is the processes, this is what it will talk to. And if you're armed with that context, now you can do a whole set of security and protection techniques far more effectively, whether that's to whitelist it, whether that is to encrypt it, whether that is to do vulnerability management on it. That's the idea behind AppDefense. And the way we did it, every hypervisor that has shipped out of this company in the last 2.5 years has this technology built in. So anything with vSphere 6.5 and above has the instrumentation. And when you turn it on in vCenter, it connects and leverages the app verification cloud. And that's where we're doing the rich analytics, where we looked at vendor information. Carbon Black had all this incredible intelligence about off-the-shelf software so that we could understand for processes and memory, actually that is legitimately part of Windows 2012 R2, or this is legitimately part of that. Combined with integrating with your CI/CD pipeline. So if you're using Puppet or Ansible or Maven or vRealize Automate, these are the tools your infrastructure and your application teams are already using to provision their applications onto the virtual infrastructure. We just tapped right into it and said, great. That's what you wanted it to be. Now I know what you intended that to be. But our most exciting work has been in the area of machine learning. Now, most of security is using machine learning to understand malware. We used it to understand goodware. It's a great application of machine learning. First of all, you don't have an opponent in goodware. You're dealing with a much smaller universe of possibilities. I'm not looking for one of 200 million problems. I'm looking for the 100 things that really should be there. And we have access to an incredible amount of visibility with between 60 and 70 million workloads running around the world. That allows us to have something we can watch the running workload against. Now, there will be lots of differences that are normal, patches, updates. But because we can see the change and say, that's just a newer version of the same software, that came through your provisioning. Or I've seen that. I've seen 10,000 domain controllers. That's what domain controllers do. We're able to distinguish what is a normal change. And if you do see something that's abnormal, you now have this flexible place to snapshot or kill a process or quarantine. And none of this involves extra agents or appliances. It's using the virtual infrastructure. The policies are not what can you do or not do. The policy is what do you want to have happen if what's running doesn't match what was intended to run. It's a beautifully simple model. And the biggest use case for it is not just the security teams, it's the virtualization, the vSphere admins, because it's about continuous private cloud hardening. Now you have workload visibility, you know what every workload is and does, and now you have workload validation. If a workload has vulnerabilities, if a workload has bad reputation software, you will instantly know. And workload protection. Now you can say, it's like change control. Now you can say, if it's not a patch and it's not an update, this thing doesn't change. And we built this, you can add this to any version of vSphere, but we actually built a new model of vSphere called Platinum that has this all built in. And then we built that into every package that vSphere is in. So if you're buying vSphere Platinum, if you're buying VCF Platinum or vCloud, vCloud Suite Platinum, all of these things have the Platinum version with this built in. It becomes the brakes in the car. You don't need to buy the brakes, but I strongly suggest you want to start using brakes. So with that, now it is time to actually see this in action. And I'm going to bring to the stage a couple of helpers, my blue team and my red team. Evan, welcome. Good to see you. Can we switch onto Evan's screen? So here's what we did. We set up an application in Palo Alto, actually a couple of applications. We set up an e-commerce system, a multi-tier e-commerce system. And what we're going to do is show some techniques for hacking into that system. There is security deployed on it. And we're actually going to use that to then break into a supplier database on a different system in the environment. I have, thankfully, my ops team sitting here in the front row. They're actually monitoring the systems in case we blow anything up. And Evan, so why don't you start us? What's the first step that you would use to attack?
So the first step, Tom, is to run reconnaissance on that website to get a lay of the land and see what public or private-facing assets they have.
Let's take a look. Now, so today, Evan's going to be using all open source, freely available software. You're running a Kali Linux box with red teams, blue teams, hackers we all use. And I think what you're using now is Nmap, right, which is one of the tools on that. So what does that tell you?
Well, what it tells us is that this website is running on port 443 SSL, running Apache Tomcat 9017.
OK, so now we know what's running on their web server, what software and what version of it. So you want to exploit that. Do you have to write something from scratch?
No, I don't. I have to go. I'm going to use the same search exploit to search for a vulnerability that allows us to leverage that attack. So
all you have to do, this is a lot of the weaponization of cyberspace. So search exploit will give us a database of exploits for various versions of different software. So now Evans is looking for exploits for that version of Tomcat.
Yep. And you can see, Tom, we're going to use the CGI servlet exploit remote code execution in our attack today.
All right. So now he's going to use that exploit. What he's going to try to do is set up a reverse TCP shell onto that web server so that we can get into the app server.
As you can see, Tom, I'm not able to get a reverse shell at the time.
OK. So we did deploy security on these. We actually have endpoint security running on that web server. And that's actually what's blocking him onto that. So next step.
Yep. So I've used the same vulnerability to query the system to see what endpoint detection is running on that machine.
OK.
And then I'll go ahead and disable that running the same exploit.
All right. So here's a problem. you're trying to run this in the same trust domain as the attack surface. So if I get root on the machine, it's very hard to protect root against root. So he is now turning off the endpoint security on that. Now you should be able to set up that shell.
Yep. As you can see, I'm in. You can see what service I'm running as.
So you should actually be able to turn endpoint security. Now that you have the shell, you could probably turn it back on.
Yeah, I'll turn it back on to fly under the radar so it seems as a blip in the system, and then continue our attack.
All right, so now we have a position inside that server. You're actually on the app server now. We want to move in the environment. We don't have a move in the environment. One of the best things for that is domain controllers, Active Directory. It touches everything, right? So Evan's going to try to move on and take a look at the Active Directory server.
Yep. I did some reconnaissance on the Active Directory server, Tom, and you could see there's a suppliers database here that seems very interesting for attack.
All right, so that's the supplier data. Now you know where it is. What he doesn't have is a credential. So your step on credentials?
The next step is to search the system to see if there's any DB credentials that we can leverage in that context to move laterally.
So one of our challenges in every one of these demos is like what techniques to show. So there's a lot of techniques for stealing credentials. Last year what we did is we did a pass the hash technique between servers using a tool called Mimikatz. We were trying to mix it up this year. We had a debate about this, but it's because it's a very simple thing. One of the techniques that is unfortunately pretty easy is a lot of data centers are using the same credentials across multiple database systems. So in this case, we're actually just pulling the credential. The first thing it's trying is pulling the credential from the e-commerce database system and using it. And it's a lot of times people are using a lot of these same databases. But there's a lot of techniques.
Yep, so we capture the credentials. And next what I'll do is I'll download another open source tool to run a query on that database using the credentials that we
All right, if you're going to break and steal data from database, one of the first things you need to understand is the schema, so that you can construct the right types of queries. So the first thing he's doing is he's downloaded an exploit to run against it so we can get the schema of the database.
Yep, I got the schema. I see the suppliers database that I wanted to target and the data that I want to dump.
All right. Now he has the credential, he has the location, he has the schema. It's a pretty simple thing to pull the data onto the app server of the other system.
Yep, I've dumped the data, and now what I'll do is I'll exfiltrate that data out to my command and control server.
All right, so now he pulls it out to the command and control server, and it's ultimately about cleaning tracks. So I think the next thing you're going to be doing is wiping logs.
Wiping logs and making sure that nobody detects it.
Evan's going to turn all security back on. He's going to put every log in pristine condition. The last thing we want to do is slow down anything in your environment. We don't want anyone complaining. This whole notion of viruses slowing down the machine, it ain't us. It's the last thing. We would like your infrastructure running perfectly. We want to go in and out, and you don't even know. All right. Terrific. Could we flip onto the PowerPoint for a second? Just so it's clear on this. And what we laid it out is actually using, and we laid it out also with the MITRE attack framework for folks who are familiar with MITRE. So what did he do? He did Recon on it using a Kali Linux box and Nmap to actually map out what software was running on that server. He was setting up a reverse TCP shell. He had to turn endpoint security. So he used the same exploit to turn off the endpoint monitoring. He then set up the shell, and he put endpoint security back on. From there, he actually went and he accessed Active Directory so we could actually frame out where the different systems were in the environment. Now he knows what he's going after and where. He needs a credential. He pulls the credential off the app server, and he uses that to get the schema of the database, and then uses that to then query, pull the data on the app database, and he's FTPing that data out. Then he wipes the logs on all of those systems. All right? That's the general idea. Evan, you are a truly evil man. Thank you.
Thank you.
All right. Let's talk about defense. Nolan, thank you.
Thanks, Tom.
Nolan is our vSphere admin. And we thought we would start with you because one of the things that we've been talking about is that vSphere admins are starting to take a growing role in security.
Absolutely. You know, my job responsibilities as a vSphere admin continue to evolve, and I'm often playing a larger role in the security of my organization, which is actually kind of a cool thing because I'm often a bridge between the app team and the security team, so it kind of makes sense for me to play some sort of role.
Yes, absolutely. So we talked earlier about one of the big things vSphere admin's doing is first gaining visibility. They actually understand you can't manage or secure what you don't understand, so the visibility of the workloads. And then the second thing is starting to do workload validation and hardening. So could we walk through that? Walk us through visibility and what you get out of AppDefense in visibility.
Yeah, let's hit the visibility piece first.
Oh, could we go to Nolan's screen?
Yeah. So this is the AppDefense SaaS Manager. And as you can see on the left side here, I have a number of scopes. And scopes are how AppDefense sort of organizes the virtual machines in my environment. And I see here I have a dashboard. And if I click on the topology piece, I can actually see how my application is actually interacting with one another. So I see here I have the database, and it is connecting out to a number of public IP addresses. And I can see here that I have SVC host. And one of the cool things is it's actually going to tell me that this binary is trusted. And we're taking that from Carbon Black, actually. So I know that SVC host is a trusted binary in my system.
All right, so now you understand the composition of the application, the roles of each of these workloads, what they do. You actually understand what each workload, and it's not just baselining, it's actually validating them against this. All right, so you have that. The next thing we talked about, hardening and getting rid of risk. So one of those is, if we remember going back to the framework, was system integrity, OS integrity. Walk us through how you do that.
Yeah, there are a number of things that the security team asked me to do, and one of those is create a checkbox for system integrity. Right. And bottom right here is the Windows integrity checks. And basically, you can just think about this really simply as the hypervisor, using our position there to protect the operating system and my underlying infrastructure. So I get this visibility directly in vCenter, and it's performing these system checks all the time.
All right, so protecting the integrity. Now we're talking about maybe bad reputation software running in the environment, odd behavior. How do you see that?
Yeah, exactly. So I also get process reputation directly here in vCenter. And if I click on here, I actually see that there are a few high-risk binaries, which is a little odd. And if I click on this, I can see that they're running on a number of different virtual machines, including App Tier 2, which happens to be the same application that's running the e-commerce site. Yeah. And I see here, again, directly in vCenter, I have a number of tabs: guest monitoring, guest integrity, and vulnerability assessment. As we know, most attacks actually start with a vulnerability.
Yep.
Something like over 90% of attacks actually start with a vulnerability. And I can click on this tab right here, and I can sort of get a better understanding of maybe there's something going on here. So I click on the app tab, and I do see that, in fact, I have an Apache vulnerability, the same one that Evan just used, version 9.0. And I can actually see a risk score for that vulnerability as well. This is a very highly critical vulnerability.
All right, now, in the past, you would have gotten a scan, you would have gotten 1,000, 10,000 vulnerabilities,
Yep.
but you still may got a lot of vulnerabilities on this. So how do you go about prioritizing this?
Yeah, exactly. As you can see here, there's actually 1,271 different low criticality vulnerabilities.
Yep.
But that's the cool piece about this. AppDefense is actually using a number of different sources to pull together information to tell me that this vulnerability is critical. So, how easy is it to exploit this vulnerability? Are there active internet breaches against it? And if I were to exploit this vulnerability, how bad would it be? Would I be able to get a reverse TCP connection like Evan just did? So we pull all that information together, and you get a risk score.
All right, so once you have these, just automatically patch them?
Not so fast. Sometimes it's just difficult to patch. Business continuity, all sorts of reasons that app teams don't like to patch. But that's why we've got VJ here, and the security team can use the AppDefense console to actually do some compensated controls against these vulnerabilities.
Is that why we have VJ here?
I think so, yeah.
VJ, welcome. Thank you, Nolan.
Yep.
Greatly appreciated. VJ, welcome.
Thank you.
So VJ is our InfoSec person who's going to be, so we just heard about the vSphere admin and their role in this, and we've talked about hardening.
Yep.
But it'd be useful to talk maybe a bit about compensating controls, but also detection and response to kind of what's going on. Now, we've had AppDefense running the entire time that Evan was on there. What did AppDefense see?
Yeah, let me tell you that. So clearly, AppDefense is a great compensating control. And Evan actually thought he was stealthy. But let's look at the alerts dashboard here.
Yeah.
So we'll reconstruct the whole attack that Evan did right here. First of all, I'd like to point out that everything here has been classified by the App Verification Cloud. So only critical alerts actually show up here.
Yeah.
So let's look at what's happening here.
Can you reduce the size of the fonts anymore?
No, I can't. It's testing my eyes here. So Nolan's got good eyes. OK. So the first thing I see here is a command shell being spawned off.
Yep.
And I noticed that it's Tomcat, which is a parent process, triggering that.
OK.
That's not common.
Yep.
So I want to check if there's any vulnerability on this Tomcat here. And I can see that Tomcat actually has a vulnerability here. Right?
Okay.
So that's the same one that you saw on vCenter console.
Yep.
This has me a little concerned. So I'm saying, what is this trying to do? And here I can see that it actually tries to disable, do a bunch of things here, and spawning off a PowerShell. So I'm going to check if there's any vulnerability on this Tomcat here. And I can see that it actually tries to disable, do a bunch of things here, and spawning off a PowerShell. So I'm going to check if there's any vulnerability on this Tomcat here.
Okay.
At this point, if a command shell is actually spawning off a PowerShell that is using a vulnerability in Tomcat, I'm surely worried.
Yep.
So I want to go back and look at the PowerShell here. And I'm going to open up this and see what that PowerShell is up to.
Yep.
I look at these, and these things tell me that first thing it tried to do was to disable the security control, which is what Evan tried to do. So I can see that right here. The next thing is it's setting up a reverse TCP shell. Again, I can see that here. Now I'm worried. What is happening on that reverse TCP shell? Let's go and have a look at that.
Okay.
Okay. So I'm going to go back and PowerShell. This one. Whoa. Just have a look here. I can tell you the whole story. So this PowerShell is talking on port 53, which is the DNS port. And command and control traffic is often uses that port. The data being exfiltrated on that port usually, so I'm very concerned. Then I see that it's talking on port 389. This is the Active Directory port. So I can see how it's trying to move laterally, get more information.
Yep.
Really worried. And then I see port 21 being used, which is FTP. So it's probably moving payload back and forth. Right?
Got it.
At this point, I'm not just suspicious. I know something fishy is going on.
Yep.
So I'm going to kill the process from here right now. Now, let me do that. You want
to kill the process? You want to bring up Evan's screen?
Yeah, let's see. OK, so there you go. I killed the process, and I want to kill that shell.
All right.
It's done.
You're dead. Okay. So the interesting thing here is that AppDefense is not trying to understand attacks. It's trying to understand what the application is intending and doing. It's listing out all the things from connecting to things it doesn't connect to turning off things it doesn't turn off, to all the activities and mapping them out in a sequence. Now, you killed it at that point, but you could have set that up to automatically react to that as well, right?
Exactly. We had to do the demo, right? So, I mean, I had to let him in.
All right. But by default, the policy sets, if you could show us, the policy sets are set up to be in detect mode, like DEFCON 5. We're just sort of watching against these things. Right, if we wanted to elevate this to a DEFCON 2 and sort of put these in to automatically respond to attacks like we were describing earlier, how would we do that here?
Yeah, so I just did that, and I'll show you how it is done. So right now it is set to block and send alert. We did that while you were demoing.
Yeah.
And it's extremely easy to do that. And you pointed out to our policy language, which is extremely simple. All you have to do is go here and just make these 3 settings to block and send alert, and you're good to go.
So that drop-down menu is just a library of responses. All you're saying is, what do I want to have happen if it doesn't match? And one of those is to block and alert.
Exactly.
All right, so you have it in block mode.
Yes.
Can we switch over to Evan's screen? And Evan, why don't you do your evil thing?
That's right. So again,
your first thing you're going to what? Set up a reverse TCP shell?
Well, I'm going to try to disable the AV again.
Okay.
And see if that works. And you can see it just kicks me out.
All right, so it doesn't allow him to do that because that's not what the application on that workload is designed to do.
And I can't get a reverse TCP shell either.
Because that's not what the application was designed to do. Getting to Active Directory?
So getting to Active Directory, thank you, VJ, for those RDP credits.
Oh, that's true. So you wouldn't be able to go onto that. So we've asked, you set it up already? RDP?
RDP, yeah, I gave him the creds here.
Okay.
So yeah,
so
I don't usually
let's assume he can get in. Let's assume he has another way to get in. He has presence on that machine.
Yep, I'll go over here and try to open up a PowerShell command prompt. And as you can see, I'm clicking away. And
because that's not what that application is designed to do. What about going after the database?
I'll try to run the database script. And you see it errors out.
Not because the system understands the millions of ways of attacking, because it understands the 50 things that this thing does. And that's all that it can do. All right, terrific. Evan, VJ, thank you so much.
Thank you.
Greatly appreciated. We can go back on the slides. Power is still on. It's good. All right, let's talk about network for a moment. Now, in the network, there's also a difference between the traditional enterprise firewalls that we've placed on our north-south boundary and the problem that we have in network security inside our east-west traffic. You know, on our north-south boundary, we're dealing with a entirely different problem. We deal with a litany of unknown hosts doing external threats, trying to break our perimeter. East-west is an entirely different problem. These are hosts that we understand, we actually know. We're dealing with fundamentally different set of challenges and a different set of things that can actually help us rethink how this is designed. So if you think about that application as not just a collection of workloads, but a big set of, when you look at things from a network perspective, it gets complicated fast, of microservices and workloads and APIs and gateways. And what's been happening is that the attackers are moving this to simply move laterally through that environment. And if we're going to start rethinking how we do firewalling internally, we need a different kind of firewall. And that's what the NSX team has been driving on this notion of a service-defined firewall. It's a firewall that understands not, when we say application awareness, most application-aware firewalls lack awareness of an application. We're talking about the topology, not just protocol analysis, what composes the application, and a policy that can move with the workload and not deal with appliances, but something we put in the hypervisor that can be a distributed service. So what you saw at the show earlier this week is this notion of NSX developing more analytic capability and more visibility to help define these microsegments in a much more intelligent way around the application, to have visibility into not just the network with things like vRealize Network Insight and things like the advanced capabilities of NSX, but also of the workload leveraging things like AppDefense. And the reason it's important to start understanding the application in this, the best way of thinking about it is as follows. Imagine an environment that has an application of those 4 circles in the middle, right? But we segment the network not by application, but by different service tiers like app servers and web servers. What we've done is we've commingled components from many applications in the same segment. So if an attacker takes a position on any one of these systems, I have freedom of movement within that segment, right? I can attack all the other app servers. And the one true thing about an application is different layers of an application have to be able to talk to each other. We actually have not solved anything. This is security theater. I can move laterally through the environment. Here's what we have done. We've created enormous complexity, because when you place a control in between these layers, you now have tens of thousands of rules. How many of you have ever removed a firewall rule? Right? It's very, very complicated because of the interdependencies between these things. But when you can start thinking about segmenting around an application, now you really start addressing the lateral movement issue. And the rule sets, the policy sets, become far simpler because we're dealing with a single application or some critical service. Right? Now, how this connects to workloads and AppDefense is a segment still has to be open. It has to be open to users. It has to be open to shared services. Right? And what you don't want is those things connecting in, not laterally, but directly infecting. But if we can align our workload security with our network security, if we can actually instrument these workloads and lock them down, now a compromised user can't manipulate those machines to do anything other than it was designed to do. Or a compromised shared service can't do anything to those workloads other than what it was intended to do. We can even run something like AppDefense on those shared services. And that's how these things start to come together. So if we can actually take a look at this system over here, and what you saw a little bit of the other day was something called NSX Intelligence. Now this screen starts to use NSX's insight into the network, as well as VRNI, and is also taking telemetry in from AppDefense on the workload side, and it starts to map out the connections and the understanding and the constructs of an application. And what we can then do is have the system start to recommend policies based on its understanding of these pieces. And they can start to automate this process. For those of you who saw us last year show adaptive microsegmentation using AppDefense, right? This is the next step in that, which is taking not just AppDefense, but correlating it with the network information and the net flow, including historical net flow logs, to be able to sort of marry and map those together. So here, NSX Intelligence, using these various components, creates an automatic policy. Now, you might scare the heck out of you to just take an automatic policy. One of the cool things is my ability to simulate this. I can actually simulate what would happen if I were to take this policy and run it over my NetFlow logs over some period of time. And now I can see what would have happened. Would this have blocked anything? So this is the kind of power that you start having with something like NSX Intelligence and the work that we're doing with the service-defined firewall. If we can go back to the main slides for a moment. Let's talk next about user endpoints and users' identities. And this is where it starts to get into the very, very exciting area of Workspace ONE. And for that, I'm very pleased to bring up to the stage the CTO of End User Computing, Shawn Bass. Shawn.
Hi, Tom. How are you?
Good. Thank you. I give you channel command.
Thanks very much. So you've seen some really cool, interesting things that we can do to protect workloads, cloud, network. And what's been happening in the security industry is as security gets better at protecting the data center and the cloud, attackers are beginning to move to the weakest link, which is the user. If I can trick the user into clicking on something, compromising their device, I can piggyback their network connection into the data center, either via a VPN or via the corporate network. And if I don't have that segmentation in place, then I can easily attack hundreds or thousands of other resources. So what we're going to talk about is how do we actually use endpoint posture and identity posture in order to protect the things we care about, which is the apps and data that Tom and team are protecting in the data center. So the way we do this is through the same principle Tom talked about earlier, least privilege. How do we make sure people have the least privilege on their device, the least privilege on the network, and the least privilege access to the data center applications and data? And to do so, we look for things like, are they coming from a trusted device? Are they who they say they are? Can we prove that their identity is accurate and that they have guaranteed their identity? And then for the transport point of view, should they be allowed into the network based on what we know of their device and what we know of their identity? If all those things are true, the user gets in. Now what we've done in Workspace ONE is built some analytics on top of this in order to not only look at all those data points, but actually start calculating risk scoring and using that risk scoring to influence the outcome on a continuous basis of a real-time decision of should this be trusted or not. This is the base premise of a security framework called Zero Trust, and Tom alluded to this earlier. So let me just give you a quick example, hypothetical. Let's say a user comes in, their device is trusted and secure from our compliance policy, their identity is trusted and secure. I'm going to let them connect through their per-app VPN into the data center, and they're going to access their application and data because it's a low risk score. If, however, the person's device is risky, there's some compliance security policy wrong with it, I may still allow them in on that device, but I might challenge them with multi-factor authentication. Think about something coming from a device they don't normally use, an internet kiosk. I just want them to prove that they're really the user we intend, and then I'll give them access to that application. Last scenario, and this is a risk score is medium. Last scenario is the person's device is not trusted, and their user identity is risky. Maybe they've had a lot of failed login attempts. This risk score is high, so we're going to flat out block access into the data center and prohibit them from getting to the applications and data. So what I like to do is show you how all of this works in Workspace ONE. So let's kick off the demo. So this is going to show two scenarios. The first one is person has a personal BYO phone, and they've gone and they decide to turn off their Find My iPhone. This may be a perfectly normal thing. They're trading out their iPhone. However, we consider this potentially risky because if an attacker has a device, they can turn that off. So when they go to access a key application like Salesforce, we would want to prompt them with multi-factor authentication or in any number of other compensating controls just to be able to prove they are who they say they are for a risky app. We could also, by the way, just block access to Salesforce if we deem the device health is risky. So we can do all sorts of different level of compensating controls. In this case, we've just chosen to do two-factor to challenge them on their identity, and at that point in time, we give them access. This same user, a few days later, is using their Dell XPS laptop, and they get this email to download 35 shareware applications. You can totally trust us, download this, install this, it'll make your Win 10 experience great. This person has clearly not attended their security awareness training because they should know they shouldn't do that. Now, when they go into Workspace ONE Intelligent Hub, they're going to see a couple of alerts here. The one at the bottom is that IT has notified them 5 times now they were supposed to take the upgrade to the latest version of Windows 10. And the latest alert says that your device risk score is elevated because of some things that we found related to your app download experience, how many applications you've downloaded. Now we're going to take a look at the admin view of this. The admin view, if you look at the bottom there, there's 4 different risk indicators we're tracking. Have they deferred updates too long? Do they have risky settings that are not in compliance? Do they have unusual applications? Or have they done a compulsive app download? So we'll go into the details of these devices. And you see Peter's phone there that's a medium risk setting. And you see Peter's Dell laptop that has 3 different behaviors that are contributing to his high risk. If we drill into these 3 different behaviors, we'll see it's made up of several different risk factors that all combined together make him high risk. He's still running Windows 10 1607 when the enterprise version's 1803 because he declined the updates. He downloaded 35 applications in the last 7 days, which is greater than 99% of every other user in the company. And the last thing, as Tom talked about, we've been working with Carbon Black for the last year as part of our Trust Network partnership. They send us security feeds of deployed agents on the devices in order to let us know that that device has some risky processes. What we're going to do now is build an automation to try to correct the situation. We're first going to fire off a ServiceNow ticket for any high-risk devices to let IT and security ops know this user's device is risky. We're going to send a push notification to the user letting them know that their device is risky, and until this is remediated, they don't get access to the network anymore. And the last thing we're going to do is block their per-app VPN access into the data center and into the applications. By doing so, this risky user's device that may be compromised no longer has access to the most important thing, our applications and our data. So that's Workspace ONE and our security story, and I think it fits very well with everything Tom showed you on the data center and cloud side. Thank you.
Terrific. Thank you. Thank you, Shawn. Every time I see Shawn present, I'm reminded that you can't patch people. All right. So we've talked about workload, network, endpoint, and identity. Let's talk about public cloud. Now, in public cloud, you still have many of the same things that we've discussed already, but you actually have a new element of it too, right? This is a shared responsibility model. It's not a no responsibility model. In a shared responsibility, the cloud provider is ultimately responsible for the hardware itself and the virtualization software, but what you're running on it is your responsibility. So there still are the elements that are about the workload and the network that we described before. It is important that you're running things like Carbon Black and NSX and all those pieces on that. But you have a new element, which is the configuration of the resource configuration of the cloud itself. And it turns out to be a huge, huge issue today. When you look at the breaches that have occurred over the last several years, it's incredible how many of them actually related to configuration issues. And you've seen headlines of that even quite recently. That's the idea behind Secure State. What Secure State does is actually leverage what is already there in the cloud and applies analytics to really understand the configuration of those components, to get contextual insights, to be able to correlate risk, to be able to automate how you can deal with these configurations to ensure that you're really operating on a trusted model in the public cloud. And for that, let's take a look at it. Jason Needham, welcome.
Hi, Tom. Thanks for having me.
Great to have you. So walk us through Secure State.
Yeah, so we had a new marketing department and some experimentation going in cloud accounts, and you asked me to hook up Secure State into those accounts. Wiring in the cloud security tool, Secure State, really just takes a couple of minutes. We go ahead and we index the accounts, and right away we get an information and a high-level view of everything that is going on in our environment. Within Secure State, we have a set of predefined policies and rules that are looking for common misconfigurations, best practices. We even map them to compliance frameworks to give ourselves an idea, so if we need to go back and kind of look at how we're doing against CIS or other standards. But let's drill in a little bit. I'm going to go into some rules, kind of look at the view that way. So what we're doing here is, within Secure State, we organize the findings around common rules and misconfigurations. And this goes well beyond some of the things that we've heard. Maybe I see some open buckets. I've got some RDS instances that look like they're exposed. This one in particular, the SSH key, this is interesting. Let's drill into this. So right here we're seeing we have an admin policy that looks like it's exposed. I'm going to go ahead and take a dive deeper here. So one of the things that we get with Secure State is not just an individual finding, but a cross-service posture assessment. Okay. So it looks like in this case, we're actually able to see that we have a policy defined in Amazon. Looks like an administrative policy for the whole account that's both on an instance that's in a public subnet, as well as sharing keys with other instances. So this alert fired because essentially someone exposed all these instances to the gateway. So if we go into the activity log, excuse me, just clicking back here. Oops, I think I went forward here. We can see that John in development looks like we established a gateway and exposed this. So we need to go talk to John and figure out if this is a state we want to stay in. Because if those keys are gone, our entire account can be deleted. They can open up buckets. They really have free range to our entire Amazon infrastructure.
Right. OK, terrific. All right. So you're talking about a little bit of automated policies, but what if I want to actually ask directed questions? I'm doing an investigation. I'm sort of querying the system.
Yeah. So Secure State basically builds a map of all the cloud resources and how they relate to each other. So we have within the tool this product around this element around being able to explore capabilities. So I'm just going to go ahead and choose a cloud account, and I'm going to go ahead and look for the instances that I've got defined in this cloud account, or I'm going to start with the IAM profile. I'm going to go and run this. So right away we can get a view of specifically the IAM profiles that we've got in this account. I'm going to look at all the instances that I've got attached to them. We get a view of the 6 instances that are in this account. I can go ahead and look at all the metadata that's assigned to that we've discovered, cloud tags, other information about each one of the instances. I'm going to take this a step further and just try to get an idea of what the posture looks like and how it is, how our security groups connect into this. So what I'm trying to demonstrate here is that we very easily can investigate and understand not just the vulnerabilities and the findings that we have within our account, but we can go and ask those questions to really better understand the issues that might crop up in our cloud environments.
All right, terrific, fantastic. Thank you so much, Jason. Really appreciate it. Jason Needham, thank you. If we can go up to the slides. Okay, so terrific. That is the general idea of intrinsic security, right? You start with a digital foundation for any app, on any cloud, on any device, and we leverage the pieces that are already there. Those unique position points that we have to actually understand the application and data from each their own perspective. The network team, the workload infrastructure team, the user device team, they all talk a common language. They all see a common language that is around the application, the thing that we're ultimately trying to protect. The analytics to be able to make sense of that data and the control points in the infrastructure and the fabric itself to enforce that policy. And of course, the ecosystem around it. And I could not be more excited about the work that we're going to be able to do with Carbon Black. It's both at the user endpoint, on the workload with vSphere in the public cloud, and the incredible analytics that are in there. VMware has actually had an extraordinary track record with acquisitions like Nicira, with NSX, and with AirWatch and Workspace ONE, and with VeloCloud. And one of the reasons that we do these really well is that we're very clear about a vision and what we're trying and finding the right technology that fits in, and about finding the right team. And it's a really, truly incredible team with Carbon Black we could not be more excited to be working with. You're going to see some incredible innovations that could not be done by any security vendor prior to being able to put these things together. An ounce of prevention is worth a pound of cure. You may be wondering who that was. It was Ben Franklin. You're absolutely right. And you may think of Ben Franklin as an author of the Constitution, an inventor, et cetera. You may not have thought of him as a fireman. You may not have thought of him as the person who created the first professional firefighting force in America. But sometimes unconventional thinking comes from unconventional sources. You may not have thought of us as a security company, but we may be the most important company in security. And we're going to be investing heavily in this area. We are very passionate. We are very committed to this area. And we'd love to be working with each of you to figure out how we can solve problems in a fundamentally different way. Now, there's a bunch of things at the show for you to check out in sessions. And some of these sessions, many of these sessions are going to be posted. The videos of these sessions. There's a whole bunch of hands-on labs where you can try these things for yourself. And after VMworld, there's a whole bunch of sources where you can learn information. So anyone want to take a picture quickly of the slide, please do. Now's the time, and it's a wonderful place here at VMworld to get educated on this. And you hope to have you back again next year when we do, in fact, attack the power grid. But I thank you for the session. Enjoy the rest of VMworld. Thank you so much.